Hi, welcome to this lesson on finance, future value annuities. Let's have a look at question 4. Brendan plans to buy a car in 5.5 years' time. He saves 30,000 Rand in a separate investment account, which earns 13% per annum compound interest yearly. If he doesn't want to spend more than 160,000 Rand on a vehicle and his savings account earns an interest rate of 11% per annum compounded monthly, how much must he deposit into his savings account after each month? Okay, so let's go ahead and put a timeline together and visualize what is happening here. Okay, so as usual, I'm going to start off at T0, then T1, T2, and T3, all the way up to, well, 5.5 years time. 5 years is 60 months. 5 times 12 is 60, plus another 6 months for half a year. So that is T66. So at the end of every month, Brendan's going to put a certain amount of X at the end of every month, and he wants to save up for the future to some value. How much is that future value that he wants to save up to? Well, he doesn't want to spend more than 160,000. So that's going to be the maximum, right? So it's going to be 160,000. However, we need to subtract from some amount, and that amount is going to be the 30,000 Rand that he saves up in a different account that also accrues interest over 5 years at a rate of 13% per annum. So what's happening on the timeline here is that he's going to have an accumulated amount of P times 1 plus I to the n, where P is the 30,000 Rand he invests into the separate account. The interest rate is an effective interest rate because it's happening compounded interest per annum. So it's going to be 0.13 raised to the power n, which is going to be 5.5. N is 5.5 here because that is dealing with years. This is the effective interest rate. So if you put that into your calculator, 30,000, open brackets, 1 plus 0.13 raised to the power of 5.5, you get 58,756, 0.06 cents. Okay, so Brendan will have saved 58,756 Rand and 6 cents over 5.5 years in that separate account. So we need to subtract that amount because that is what he's also going to use to pay off the car. So the future value he's actually saving for is this answer, 160,000. So I just did minus 160,000, but I'm going to take the positive value. So it's going to be 101,243 Rand. 243 Rand and 94 cents. So what I'm going to do is, I'm not going to round off here. I'm going to store this answer into my calculator as A. So I'm just going to make sure it's positive. Okay, and then I'm going to go shift store A. So now if I click alpha A, I can see I get that value. So that's going to be the future value. So using the future value formula, F equals the number of payments X times 1 plus I to the power N minus 1 all over I. Okay, so what is the I in this scenario? In this scenario, it is 0.11 over 12 because it's compounded monthly. Now I'm going to store that into B into my calculator because I've already got something for A. So I'm going to go 0.11 divided by 12, and I'm going to go shift store B. And now if I click alpha B, I'm going to see that that is the interest rate there. So now I can solve for X here. That's what we want. So we want to know how much does Brendan deposit into his savings account after each month, right? To attain this future value of 101,000. So therefore, if I solve for X, it's going to be the future value times the interest, all divided by 1 plus I to the power n minus 1. So in my calculator, I can go ahead. The future value was that value A that we worked out, times the interest rate, which we called B in our calculator, into 1 plus the interest rate of B. So just be careful what you put into your variables. Raised to the power, now n here in this timeline was 66 months, right? 5.5 years minus 1. And I get 1,123 Rand and 28 cents. So that means Brendan must deposit 1,123 Rand and 28 cents for 66 months if he wants to get this amount here, 101,243 Rand and 94 cents, because that's how much he's going to need at maximum after he's already used this other 58,000, which was attained from that savings account of the 30,000 Rand over 5.5 years. Okay, so there were two different things we had to keep in mind here, and as we did them correctly, use the correct formulae, we were then able to find the deposits that Brendan would have to make. All right, I'll see you in the next one.